Hello. Morning. You should see the desktop. You should hear me. Sorry, I'm late. Zoom and Boiler Key weren't cooperating a little bit for a while. Okay. So do you see the desktop and do you hear me at this point?
Yeah, I
Okay,
can see it and hear you.
great. Thanks. Um, okay. Today we're going to do more examples of using nested for loops to draw some pictures. Okay. So we're going to keep playing with examples like that. Okay. Okay, so I put the examples in a folder this time that I'm going to download. Now, now here's like what we've been doing in the last few examples we did in class the other day. We did, yeah, we wrote the code to draw that pattern there, okay, and we wrote the code to draw this pattern here. So we're going to do more patterns like these, using various forms of nested loops. And this is it's really nested loops are really ubiquitous in computer science. People write nested loops all the time, partly because of tables. Because if you notice that this data kind of, if you, it kind of is a table. The part we drew, there's spaces over here and dots and numbers over here, and kind of like we're kind of laying out a table. Okay, so that's one reason why nested loops are popular because you lay out tables, and then nested loops are just when you're having to do one job inside of another job. When you have a job that involves like a real famous example is doing multiple batches of laundry. You know you. The inner loop of doing multiple batches of laundry is put the batch in the washing machine. Then after it's done, put the batch in the dryer. Then after that's done, fold it, then start over again. Put the batch in the washing machine, put the batch in the dryer, fold it. It's a nested loop of things to do. The inner loop is wash, dry, fold, and the outer loop is do the next batch, do the next batch, do the next batch. And you can kind of imagine that that's ubiquitous, that there's nested groups of things to do. So those get expressed in computer science as nested for loops. The outer loop would be pick the next batch of laundry to do, and the inner for loop would be a thing that makes you go through three steps of wash, dry, fold. Okay, so nested work is real common. So and a nice way to express that is with pictures. Pictures are a good way to think about practicing with nested work. Okay, so here's a zip file of a bunch of examples. And we're going to add also one new feature to our examples. We're going to start, see the new reading assignments. We're going to go back to talking about methods. So I'm going to do these patterns over here. Some of them I'm going to do over again, but we're going to do them using the idea of methods. So I got the folder downloaded. So unzip it. Okay. And you notice there's a lot of examples in there. Okay. I've got 11 Java programs, okay, in there. And then there's this picture file. There's this file here that's it's just you can just double click on it. Yep, it's just you double click on it, it'll open in Notepad, for example. Okay, you could open it in you could open this file in Dr. Java too. It's There's the patterns we've been drawing. So we've done all these, we've done these, we've got examples of doing those. The Here, the pattern changes from just doing stars to doing same pattern but with numbers. Okay, so you could change it from being just spaces and stars to spaces and numbers. But if you do spaces and numbers, then you can change the pattern of how the numbers are written, which gives you something more to think about. So this one's counting up to 6, 6, 5, 6, 4, 5, 6. This one's counting down from 1, 1, 2, 1, 1, 2, 3, 1, 2, 3, 4. Yeah. So there's just a lot of different ways of laying out. This makes you just think of more patterns. You know, Here you had to think, how do I get that shape? And then here you have to think of how do you get that exact same shape, but also get these numbers to do something within the shape. And here you have to get the exact same shape, but the numbers do something different within the shape. So you're having to think deeper into the pattern and get the right thing to show up on the screen. Okay, and here's another example of that same shape. Okay, notice that this one had 1, 2, 3, 4, 5, 6 counting on the diagonal. This one has all ones on the diagonal. This one was counting down from 1 on the right. This one's counting up from 1 on the left with ones on the diagonal. This has got ones on the right edge. Little things that change the pattern. Okay. Now let's see. I forget where we ended. I think we did all of these. Okay. So we did all of those. See where we ended up with a variation on one of those. We did it with the numbers on a diagonal and the dots. So that's not in, that one's actually not even in this list of patterns. That's another one that you could put in that list of patterns. Okay, there's the pattern, that one. So there's that last pattern there. Okay, now what I want to do is for each pattern here, there's a program that does the pattern. So they're not quite the same ones that are up on the website though. Like take this one here. Okay. We did that in class. A while ago. Let me see so that's stars going. Let me find where that one was. Was it over here? Oh, we probably didn't do that one specifically. I think we did it with, well, it would be, to get that pattern, you just take the one that has numbers in it and change the numbers to, oh, yeah, all these have the spaces on the left. So so for example, this one here. Okay, this one here would be, you get that one from, keep forgetting what order these are in. There, yeah, you can get this one from that one just by changing this to a star. Okay. Okay. Oh, I printed a plus instead of a star. Okay, so there's that one. Okay, so now, but this is the third pattern here. Well, this is pattern 1. This is done by pattern 2. So if you look in this program here, okay, it does that same it does those, it does those. Okay, so there's the program that does these. Okay, so that's the same idea as what we did right here. Okay, if I could fix that. So that was supposed to be a star. Okay, now I'll show you what there's gonna be something different over on in the new version. Okay, so there's the code that would print that right there. Okay, now let's compare the way we did it to the way it's done over here. It's going to be done a little bit different on the left. The new code is just a slight bit different than the old code was. Okay, the old code, the loops just sat right in the main method, and they had this integer rows which said how big it should be. Remember, if I change this to 10, then I'm going to get 10 rows and 10 columns. I'll get 10 rows and 10 columns. Oh, so now I've got 10 rows and 10 columns. Okay, if I set it to 12, 15, I think I'll get 15 rows and 15 columns. But remember, the visualizer stops us from getting too many rows and columns. Yeah, see, the visualizer stopped me from doing that many rows and columns. So I didn't get 15. Okay, that's one advantage of having them over here. You can run them in Dr. Java and get as big a pattern as you want. There's no limit to the size of pattern in Dr. Java. Okay, now, so one difference is that these are over here in Dr. Java, these are over here in the visualizer, so they don't run as fast. But the thing is, here it's just a number that we use inside our main method. Over here, I've written a function for each pattern. So here's a function that draws that pattern. And then there's another function that draws that pattern. But the function takes the size as a parameter. So here I can call the function with size 6. Here that I call the other one with size 6. And there's actually then this one, this is just writing one of the patterns as a different way. I don't even remember which one. It's either this pattern or this pattern written a slightly different way. And I don't remember which one it is. We'll run it in a minute and see which one it is. But it's one of those two patterns written in a slightly different way. Okay. So over here, we've turned these things into methods. Over here, everything was written in the main method. So everything was written in the main method. You can only draw one picture because it was written in, unless you duplicated this code. And you set the size of the picture with this constant. Now, if I want, I could go over here and I could draw a size 6, a size 7, a size 8, and a size 9 in a row. Now, I wouldn't be able to do that in the visualizer because there would be way too many loops. Now, actually, let me open this in Dr. Java. I can't run it in this program because this is just an editor. So I should have opened it in Dr. Java. So let me open that in Dr. Java. Okay. Now, one of the things we want to do is start seeing how methods can make things better for us. So besides learning to write just for loops, oh, was that the wrong? Okay, I was working with pattern 2. Okay, besides working with patterns, we can also say, well, we can write a method to draw the pattern. See, by putting the pattern in a method and having that size be the input parameter to the method, I could actually draw lots of patterns. So if I compile this and then run it, I get the size 6, 7, 8, 9 pattern. I asked for a size 6, 7, 8, 9 pattern. So there it is, 6, 7, 8, 9, which gives me another gives me a pattern of patterns. Okay, I get this growing, like half of a Christmas tree. And then there was pattern B and pattern C. Now pattern C was just a redo of pattern B. So I was writing the second pattern too. B and C just wrote this pattern two different ways. And if I wanted to, I could make them multiple sizes too. So I could do pattern B in, real quickly, 6, 7, 8, 9. So I could get a size 9, a size 8, a size 7, and a size 6 of the other pattern. That's the beauty of methods. Once you've put code in a method, what we think of it is, sometimes it's taught is sometimes one way explained is, this teaches Java a new word. So you can use that word in your programs. So people think, it's thought of as functions like in mathematics, but it's also thought of as like a language where I'm writing something in this language and I need a vocabulary. And methods are where you give definitions to words, which is what a vocabulary is. Okay, so a vocabulary is create new words with definitions, and then you use those words to represent ideas. Okay, so a physicist can invent an idea like energy. which would have been something, yeah, it makes a new concept that you can talk about. You politicians can come up with a concept of democracy, which gives you a word, which gives you a whole concept of what to think about. So this is teaching Java a new word that I can use to write programs with. Okay, so I have a bigger vocabulary now. So that's a good way to think about it. And now that once this word has been defined, I can use it over and over and over again. Now, unlike words, these things take parameters. Okay, that's where the analogy breaks down a little bit. These things are new words, but these words take parameters. Okay. And so if I compile and run that thing, well, I hit the wrong button. Yeah. There I get one pattern, size 6, 7, 8, 9. Then I switch to the other pattern. There's 6, 7, 8, 9. And then there's that last one of the redrawing of the size 6 of that pattern. Okay, so one of the things that's all the examples in this folder are written in using methods. So all the shapes that are in here, each shape has its own method. So there's a method now for every one of these shapes, and the method takes a parameter. And we'll see that actually in some of them, the method can take more than one parameter. Like, see that pattern there? Well, one of the things you could say is, well, what about that dot? Maybe it should be part of the parameters. Maybe you should get to choose what goes after the number on, the number goes down the diagonal, and you could give the method a parameter that says, here's what to put after the number. Okay, so like that, this is pattern 1, 2, 3. So look at pattern 3. I don't remember if I did that or not in here. Let's Okay, like right now, it doesn't use a parameter for this one, but let's change it. So all I would do is say, I want these shapes to have a size, and I also want there to be a character, C, that they use for the right half of the picture. Okay, so over here, well, here's where I print the right half of the picture. So just put the character C there. That's all you have to do. I've changed what was a dot to being, that's the character. Okay. Then over here, I have to say, well, print 6 using the dot character. Okay. And then I can redo that. And now that's what we were doing before. Now here would be do something different. I'll print 6 using the @ character. And then I can do, well, print a size 10 pattern using the percent character. Okay. I've made my picture more versatile. Now my method draws that pattern, and the parameters are out the size of it and what would be going on the left-hand side of the dots. Okay. So compile this and run it. Okay. Okay, there's a size 6 pattern two ways with dots followed or with ampersands. Okay. Here's a size 10 pattern. Oh, remember 10 doesn't actually work very well because once you get a 2-digit number on the diagonal, it actually it breaks the pattern. So these patterns these particular patterns only work with single-digit numbers. But there's the pattern with ampersands on the right. And if you like this a lot, you could even say, well, the thing you print on the left of the number, that could be a parameter also. So you could go back over here and say, oh, I could really have two parameters. I could have a char 1, or a char L for the character on the left, and a char CR for the character on the right. Okay, here is where I put the character on the left of the numbers, and this is the one that was the characters on the right of the numbers. Okay, and then over here, I could say, on the left of the numbers, I want, say, space character, which is what I had before. So this reproduces what we had before. Spaces on the left, dots on the right. And then over here, I can do something. I can do um, dashes on the left and the ampersands didn't look very good. Let's see, what would be on the right? I can put, say, up arrows, okay? And then I have to change all of them. See, now once this method needs 2 parameters, I can't use, see, if I try to compile it now, I'm gonna get an error. See, I forgot to change this to match its declaration. Now it's the method says I need 3 parameters, a size, a character, and a character, and I didn't change it up here. So here I need something, well, I'll put ampersands on the left and something, and I can put ampersands on the right too. Okay, I can do it with just saying there's no reason why I can't use the same character on both sides. So compile it, run it. Okay. Notice that the first one's just like it was before because I put spaces on the left and dots on the right. Then here it is with, see, now it looks more like a table. There's spaces on the left, these little up arrows on the right. And then this one, which doesn't look so great, it's got numbers on the diagonal inside of all these ampersands. Okay. And if I wanted to, I could put spaces on the left and right. Let's see, make this 9 and put a space on the left and a space on the right, and then you'll just have the diagonal. Now, designing code to take a choice of parameters is very much what programming is about. Taking this code that did this and saying, well, what would make that code more versatile? What are the parameters in this block? What are the things you could change? Okay, and it's got numbers on, the 1, 2, 3, 4, 5, 6 seems to be the main part of it. It starts at number 1 and goes up to it puts the row number here. But clearly what it put on the left and what it put on the right of the dots could, those are obviously could be parameters. You could change what goes over here, you could change what goes over here. And if you wanted to, well, you can't, like, to change what goes on the diagonal would be a big deal. Like, if you want count of numbers on the diagonal, or you just want some particular character on the diagonal, really changes the way the code would look. Okay, because that's not a parameter. That would not be an easy parameter, because see here, to get the thing in the middle, you printed the loop parameter. Now, if I change that to another character, I can change that to some character. Okay, but how can I switch between? Yeah, it's kind of hard. Like if I compile this, oops. Oh, I there. This would kind of see, this change would be hard to make into a parameter. Okay, I know I got X's on the, instead of counting up, I've got X's. But what would be a parameter? The parameter could be that X, but then how would I switch it back to being a number? The number had to be the loop variable. When it was a number, this was the loop variable, and the loop variable can't be a parameter. Okay, let's see. The loop variable, let's see. The loop variable can't be a parameter. Okay, so there, the print thing can be either, see, this can be a parameter, or it could be the, ah, no, or it could be the loop variable, J, it was J, okay? But J can't be a parameter. J is a variable running through the program. I can't put J up here as a parameter. So changing whether it prints a number on the diagonal or prints a character on the diagonal, that would be real hard to make a parameter, okay? Because it was something that varied as the thing was count as it was going through this loop. This was changing 1, 2, 3, 4, 5, 6. So it wasn't any one fixed thing. Okay, so it would just be hard to make the change from this pattern back to the 1, 2, 3, 4, 5, 6 as a parameter. But it's easy to change these things as a parameter because they're always the same. See, there's just a, so it's a little bit tricky to think, in this pattern, what can be a parameter and what's fixed? What idea is fixed in the parameter? Like right now, it's fixed that there's a character on the left, a character on the right, and a character down the middle. I could make those three different parameters, but then I couldn't switch to having a number on the diagonal. If I want a number on the diagonal, that's not really a pattern. That to get the number on the diagonal, I need oh, that was supposed to be an I. I'm sorry. That was the row number. That was the row number of where we were. See, I need to use this loop parameter. That's the row number, and I need to print the row number. So that's I is not a, it can't be these things are fixed. Whatever these parameters are, they keep their value all through here. I want this number here to be a variable. Okay. Okay. So now there are ways to make it, there are ways to do a little bit. I could, for example, I could change what this number starts with. Instead of being 1, 2, 3, 4, 5, 6, I could have it 2, 3, 4, 5, 6, 7. But since there's such a limited range of numbers here, it's not worth it. But I could maybe change where the number started with using a parameter. Okay. I could, I could do a little bit with the number on the diagonal, but not much. Okay, now if I can run this, see, now I'm back to having the numbers on the diagonal. Okay. So in this case, if I ask what could be a parameter and what can't be a parameter in this pattern, or what can be a parameter and what can't be a parameter in this pattern, it's pretty clear that the spaces on the left could be a choice. The dots on the right could be a choice. The fact that I'm varying these numbers here probably doesn't make it easy. It would be hard to make what goes down that, that's the number of the row, that's the number of the row. So it'd be kind of hard to make that a parameter because it's doing a specific thing. It's the number of the row. Okay. So all our patterns here will be written as methods. And then that's an idea. We've talked about methods and we're gonna start using them a little bit more. We talked about them, then we kind of stopped talking about them. Now we're going to talk about them again, but we're going to put our nested for loops inside of method. Uh, we're going to give them names. We're going to give our nested for loops a name and pass it parameters. Okay. Now let's go to an example we haven't done. Oh, let's see. Let's do one other thing. Like in this one, I did this pattern more than one way. Okay. See, there's a if you look at the output, well, let me go back. There's a version A, a version B, and a version C. Okay. Okay. So the version A right now is done with parameters. Okay. So there's version A that's printed this way with the diagonal going this way. Version B has the diagonal going the other way. Okay. Right. So there's two directions for the diagonal, from right to left and from left to right. And then the one with the diagonal going from left to right is done two ways. So let's see what's different about them. Like, why did I write two loops, two different methods? I did this one as a method B and a method C. Okay. So method A did this pattern and methods B and C both do this pattern. Okay. Why did I want a B and a C? Let's see what I did differently. Okay. Okay. In B, this outer parameter is the line number. Well, let's see if we can find where did they differ. Okay. See, they both start out here. Okay, that line number, that line is the same here and here. Okay. For I equals 1, I less than or equal to size, I plus plus. For I equals 1, I less than size. So I is the line number. So the outer loop is saying line 1, line 2, line 3. Well, I'm working down here. Line 1, line 2, line 3, line 4, line 5, line 6. Okay. Then what do I do inside? Okay. Oh, I'm sorry. I'm looking at the wrong two. Ah, I'm sorry. These are the two, B and C. Okay. So B and C, no, they start off different. Like this line here, the outer loop here is not the same as the outer loop here. Okay. Okay. The outer loop here the outer loop here says what line number I'm on. That's like the A was. A and B both use the idea that the outer loop says I'm on line 1, 2, 3, 4, 5, 6. I'm on line 1, 2, 3, 4, 5, 6 again. Okay. This version C does kind of a funny count. Version C, the I counts how many dots there are in the line. Okay. So what I'm doing is I'm saying print a line with that many dots, then print a line with that many dots, then print a line with that many dots, then with that many dots, and then finally print a line with 0 dots, and then fill up the rest of the line with a number and spaces. Okay, but the outer loop is a little bit quirky of a way to do it, but the outer loop is picking how many dots there are on the line. Okay, all right. Now I'm counting down on the number of dots. See, the number of dots counts down. Okay, from 5, 4, 3, 2, 1, 0. So the number of dots counts down, and I want to stop when there's 1 dot on the line. Well, uh, I want to actually, the number of dots on the line is I minus 1. Okay, so I'm stopping when there's 1 minus 1, which is 0 dots on the line. Okay, so I isn't the number of dots on the line. I minus 1 is the number of dots on the line. Okay, I is actually the length of the line. Another way to think about this is I is how long the line is, but how long the line is, one less than that is how many dots there are. So you could also say that I is the length of the line. Okay, so that's another way to think about it. I is the length of the line. I minus 1 is the number of dots on the line. Not clear which is a better way to think about it. Okay, all right. Now, the I tells me how many dots are on the line. Okay, then this is going to print the spaces. Then I'm going to print the number. Then I'm going to print the dots. Printing the dots should be easy because I minus 1 is how many dots there are. You know, we agree that I minus 1 is the number of dots there are. So I just count up from 1 to I minus 1 and print a dot. So that's the easy part. The 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 right-hand side is I. I says how many dots there are. Okay. Now, what number goes here? Well, that's kind of weird. How do you get that number from how many dots there are? That number is 6. Well, it's size minus the number of dots. That number there is size minus the number of dots. You can think of it as this is how many, it's how many things are to the left of the dots. See, there's 6 spaces across, there's 4 dots, so there's 2 spaces to the left, so I want 2 there. There's 3 dots here, okay? So size minus 3 is 3. That's how many spaces are left here, and this number is how many spaces there are to the left of the dots, okay? So what I print in the middle is, oh, I wrote it kind of funny here, okay? It's size minus the number of dots, but the number of dots is I minus 1, okay? So if you look over here, this number here is the size minus the number of dots, okay? So it's size minus the number of dots. But we agree here that I minus 1 is the number of dots. Now I do a little bit of algebra on that. Size, if I do algebra on that, that gives me size minus 1 minus negative 1, okay? And then negative and negative 1 is this plus 1, and this minus 1 here is this minus I. Oh, that's a minus I. Okay, that minus I is that one, and minus 1 is plus 1. So I did a little bit of algebra on to get this formula here, which I thought was just easier to read it that way. Size plus 1 minus I. Okay, but if I look over here, I got it from saying that if I know how many dots there are, that leaves size minus dots spaces to the left, and this number is the amount of spaces there are to the left of the dots. Okay, Then what about how many spaces there are? Well, there's always, okay, the number of spaces is one number less than this. See, if that number is 3, there's 2 spaces to the left. If this number is 4, there's 3 spaces to the left. So whatever we just finished calculating that number, the number of spaces is 1 less than it. Okay? So if this is the number that represents the on the diagonal, if I subtract 1 from it, size minus I, see, size minus I is the number of spaces. Okay? So I can do size minus I spaces, size plus 1 minus I is the number on the diagonal, and then this one prints the what's on the right. Okay. Notice that this is not better by any means than this. This one was more straightforward. I is the line number. Okay. So will you print the line number? Okay. How many spaces are to the left of the line number? I minus 1. Okay. See, if you're in line 1, there's 0 spaces. If you're in line 2, there's 1 space. If you're in line 3, there's 2 spaces. And how many spaces are to the right of the line number? Okay. Well, okay. See, you've done that many spaces. On line 2, you've done 2 spaces, and that's how many you have left. On line 3, you've already done 3 spaces, and that's how many you have left. On line 4, you've already done 4 spaces, and that's what you have left. So the number of dots is size minus I. Okay, so this is probably a little bit easier to understand than this one. This one's a little bit quirkier because it chose the I to be something funny. I is how many dots there are. Okay, now when you write code like this, it's not, there's never a clear sense of what you're supposed to count when you do these rows. Quite often, the row number is the easy thing to say. I'm on row 1, row 2, row 3, row 4, row 5, row 6, but not always. In some examples, it'll be, you might want to count the things that are like here. I'm in the other loop, I'm counting what's over here. Instead of saying what line number I'm on, I'm actually counting what's over here. Okay, so in this case, I ended up with a harder loop. By forcing myself to say, well, this thing counts how many dots there are to the right of the diagonal, it actually made things probably a little bit harder. But depending on the code you're writing, you may be forced to think in a slightly harder way. You don't always have the choice of thinking of things the easier way. So what you have to do is you have to learn to read. You have to learn to read the more complicated one at the same time you can read the easier one. Yeah, in the real world of programming, you don't get to choose what other people write. And sometimes you have requirements that force you to use a slightly more awkward piece of code when you would rather use a simpler piece of code. So as part of also just practice learning, we need to understand how this works and how this one works. What's the thinking in this one? You start by letting I count the dots. Then given that I is counting the dots, then you have to figure out, okay, what's the number on the diagonal? How many spaces are there to the left of it? Given that I is the number of dots. Well, I minus 1 is the number of dots. Okay. On the other hand, the easier one was I is this number in the middle. That's the I. I is that number. Then to the left of it is that number minus 1 spaces. To the right of it is size minus that number dots. Okay, that was a little bit easier over here. So each one of these examples usually has a kind of an obvious way of doing one of the patterns and a slightly less obvious way of doing one of the patterns. Okay, so I varied them. So these examples, there's the what you might call the right way, which is the more obvious way, and then a slightly less right way, a slightly less obvious way, but still a good way to understand, a way that you have to kind of think about them. You have to be ready to understand these less obvious ones at the same time that you can read these obvious ones too. Okay, now let's do one we haven't done. We did almost all these patterns. Like let's look at the code that does that letter N, and notice that what the parameters are is, okay, the size of the parameter, see there's the size of the of the shape. It's a letter N that is 1, 2, 3, 4, 5, 6, 7. So it's 6 plus 1 rows, and it's 1, 2, 3, 4, 5, 6, 7. It's actually 6 plus 1 columns and 6 plus 1 rows. Okay, right? So I mean, I'm not sure if I should have called this size 6 or size 7. Yeah, you could do it either way. But I say I put zeros on the left. If I'd have put ones on the left, then this would go count 1, 2, 2, 3, 4, 5, 6, 7. And then I maybe would have said it's size 7, but I chose to put a 0 on the left and count up to 6. So it's my choice. I call that size 6, even though it's got 6 plus 1 rows and 6 plus 1 columns. And it puts zeros on the left edge, size on the right edge, and it counts from 0 up to size on the diagonal, and it ends up kind of drawing a letter N. Okay, so let's look at how that one would be. Okay, now that was let's see this is pattern 1, pattern 2, pattern 3, pattern 4, pattern 5, 6. This is pattern 7. Okay, so I'm pretty sure this should be pattern 7. Okay, see there. Okay, there's the what looks like with size N. Okay, if I want to now notice it, there's going to be two versions of it. Okay, there's going to be two versions of it. One's going to be more obvious than the other. If I could vary this and I can get different sizes. So I could get a size 5, a 6, a 7, and an 8. Okay, that's the nice thing about making it a method. If I make it a method, I can just keep reusing it. Okay, let's see what it looks like. Oh, I've clicked the wrong button. Okay, now notice that they all run into each other. So what I really, to make this more readable, I realized, oh, I should have put, see, I had it here. I should put a space between them. They don't really look good without space between them. So I'll put a space between them, make it a little easier to read. So compile again. The space isn't really part of the pattern, so I wouldn't want to put that in the pattern. The pattern should just draw this. It should be up to whoever is using it to decide if they want a space after the pattern. I wouldn't put a space in the pattern because then someone couldn't use it as they couldn't just put two of these next to each other. So I wouldn't force someone to say you have to have, even though I'm putting space, blank, I'm putting blank line, blank line, blank line, blank line. I don't think it'd be a good idea to make the blank line part of the pattern because then I wouldn't be able to use the pattern without the blank line. So here, that would be a design choice of mine. I think the blank line should be up to whoever's calling the method. If they want a blank line after it, they put a blank line after it. But if I put the blank line in the method, it looks like I'm not duplicating code, but then I don't give people the choice of printing out the output without the blank lines. Okay, so I think the blank line should be outside of the method. And those are the kind of choices you have to start thinking about. When you see me doing puzzle, blank line, puzzle, blank line, puzzle, blank line, you just think, okay, maybe you really ought to put this inside the pattern. So the last thing in the pattern is a blank line. But then after a while, you might think, well, that limits what people can do with the pattern because it forces there to be a blank line. So you can decide maybe that's not what I want. Okay, now there's size 5, 6, 7, 8. Okay. All right. So now let's look at how the code did this. This one's actually a little bit tricky. It actually even needed a helper function. I actually wrote this one using a helper function. Let's see. Actually, no. The second version makes use of the helper function. This one doesn't. Okay. So the second version makes use of the helper function. So actually, I should have wrote this with. Usually we put the helper function after the function that uses the helper function. So I should have put this down here. This is a helper function to make the other function a little bit easier. We'll see. We'll talk about that in a second. So, this method is called inside of, where is it? I thought where is it used? No, I forgot what this method here is for. It doesn't seem to even be. Maybe I made a mistake and left it in there, and maybe I used it. But some of these examples I changed them in class last year, and I may have done something and then left this in there and forgot that it shouldn't be in there because it actually doesn't look like it's being used anywhere. Actually, find out. Delete it. Compile. Oh, there's where it's used. Okay. Yeah, it is being used. Oh, it's being used right here. Okay. Okay. So it was being used. Okay, so let's look at how this. Okay, so there's two versions. One version starts off with this helper function. It starts off with the helper function. Okay, let's see if it worked completely. See if I got it back to, yeah. So I got it back fixed. Okay, all right, all right. So now let's think about let's think about let's just look at the shape and think how we might do it. Okay, now here's why I need a separate little helper function. This line and actually this line down here are a little bit different than these lines in the middle, because the lines in the middle have more parts to them than the first and the last line. Okay, notice actually, first of all, notice that the first line and the last line look exactly alike. So the first line and the last line are the same. Okay, so this thing starts and ends with that one line. See, one line does the first line and the last line because they're the same. Now, what's different about this line from this line? Well, this line's only got three parts to it: a number, a bunch of spaces, and then a trailing number. This line's got more parts to it. It's got a number at the beginning, then it's got a number, then it's got spaces, then it's got another number. And in fact, if you look at this line here, it's got even more parts to it. Number, fixed number on the left, certain number of spaces that's changing, a number, and then more spaces that are also changing. Okay, so if you think about what it is a line like this in the middle has got 1, 2, 3, 4, 5 parts to it. It's got the first number, which is always 0, a number of spaces, which is increasing, the number to print on the diagonal, which we'll treat as the line number. We'll treat this as line 1, line 2, line 3, line 4, line 5. Then some spaces on the right, which are decreasing. The number of spaces is decreasing, and a last trailing number 6. Okay, so now notice that inside here, this looks a lot like this. See, the diagonal here, if you think about it, that diagonal actually looks a lot like this pattern here, because this pattern here had the line number on the diagonal, growing number of spaces on the left, and shrinking number of spaces on the right. Growing number of spaces on the left, shrinking number of spaces on the right. So this example that we were playing with, that actually is what's inside of here. In fact, we could probably copy the code. If we go back, we could probably take the code from this and manipulate it to be this, because it's Now, but this one's got a little bit different. It puts something on the left edge, whereas this one doesn't have anything on the left edge or anything on the right edge. The pattern's actually inside. The pattern's inside there. It's in this box inside of here with zeros on the left edge and sixes on the right edge. All right, so we've seen, but notice that the pattern's kind of is being reused. So we're going to think of it as one line by itself that gets reproduced down here. So we'll treat that line as its own method, that we can just say one line beginning, one line at the end. And size is how big that line is. Okay, let's look at how that would be done. Size is actually counting 1, 2, 3, 4, 5. Okay, there's size minus 1 spaces. See, the size is 6, but there's 1, 2, 3, 4, 5 spaces in there. So it's 0 followed by size minus 1 spaces followed by a 6. Now the size minus 1 spaces is what we need a for loop for. Okay. Okay. So here's one line with size. We print the 0. Okay. We print from I equals 1 to strictly less than size. That's the same thing as if I said up to and including size minus 1. It's up to you to decide whether you like to write it one way or like to write it the other way. So I'm going from 1 up to size minus 1. That's what we said we needed over here. We need size minus 1 spaces. Most programmers don't write it that way. It's from 1 to up to and including size minus 1. They just got in the habit of writing it as up to but not including size. So count up from 1 up to but not including size. That's the same thing as going up to and including size minus 1. That prints the spaces. Then you print size as the right-hand column. So the variable size is the number that's printed on the right-hand column. Okay, so that code takes care of that row, which is also that row down there. Okay, so now what's left in here, this loop here is going to do the size number of rows. There's the 1, 2, 3, 4, 5. Well, 5 size minus 1 rows. So now here I've got 1, 2, 3, 4, 5. So I've got size minus 1 rows to do. Okay, so here's the loop now that's going to do same. Now there's the size minus 1 rows. I go up from 1 up to but not including size. So I use that idea again. So that loop is size minus 1 rows, from 1 up to size minus 1. Okay, so and then what do I do inside? I need inside each one of these rows, inside of each of these is 3 pieces: spaces, number, spaces. Okay, so now inside one of these lines is 3 pieces: spaces, number, spaces, just like it was when we did this example here. Spaces, number, spaces. Okay, right? So now in here, I'm going to have a loop for the spaces, print the number, loop for the spaces. Okay, how many spaces there are? Okay, now you have to kind of, I is the line number. How many spaces are there? 0 spaces. 2, the line number is 2, there's 1 space. Line number 3, there are 2 spaces. For line number 4, 3 spaces. So the number of spaces is 1 less than the line number. The line number is I. I is the line number. The number of spaces is 1 less than it. So count up from 1 to not including I. There's I minus 1. Okay, notice I'm using that trick over and over again. I want to count I minus 1, so I count from 1 up to strictly less than I. If I don't like that trick, I can write this I minus 1, but that's not the way most programmers would write it. Okay, most programmers wouldn't write it j less than or equal to I minus 1. They would just say, oh, you can shorten that to that. And they're very used to it. So they programmers get real used to this trick, so they read this real easily. Okay, if you put the equal sign in there, then they think, oh, you're doing something different. Yeah, so if you put the equal sign in there, programmers are more likely to think, oh, you're doing something different. Let me think about what you're doing. Okay, all right, so we're going from 1 up to I minus 1. Okay, print spaces, print the row number, print the row number. Now, what's left to do? Okay, well, on the first row, 1, 2, 3, 4 spaces. In the second row, 1, 2, 3. Now, 4 spaces is 6 minus I plus 1. Okay, it's 6 minus 1, 2, 3, 4. 6 minus 2. See, it's 6 minus 2, and 2 is 1 more than that. Here it's 1, 2, 3. Okay, 3 is 6 minus 3, and 3 is 1 more than that. 1 more than that. So the number of spaces is 6 minus I plus 1. The number of spaces, well, what it is size minus I plus 1. Okay, that's how many spaces there are. Okay, now do a little bit of algebra on that. That gives me size minus I plus 1. Okay, so that's size minus I, oh, I'm sorry, minus 1. Okay, so that's 1 less than size minus I. See, it's 1 less than size minus I. But 1 less than a number is that trick of using a less than symbol here. So I use strictly less than size minus I. Okay, that's how many spaces I want. And so I use J up to but not including size minus I. So I'm using that trick in a tricky way. I'm using the trick that this is really counting up to I minus 1, because that's how many spaces I want. I look over here and I see what I want is size minus the quantity I plus 1. Yeah, I figured that out from over here. That's 6 minus 4, or that's 6 minus 3. 3 is 1 more than I. Okay, so size minus I plus 3, do an algebra, then realize I can just drop the I minus 1 by using a less than here. Okay, so then I get that there's counting the number of spaces at the end. Okay, so I end up with this, print one line by itself, print one line by itself, then print the middle lines, excluding the first and last line. Each line has 3 pieces to it. Well, each line has actually 5 pieces to it. The number at the beginning, the spaces, the number in the middle, more spaces, the number at the end. Okay, okay, and that'll draw this. Notice it's a fair amount of code. It's a fair amount to think about. Okay, I wouldn't think of this as an easy problem. If this was a homework problem, I wouldn't think of it as an easy one. Okay, there's a lot of parts there. There's a lot of things to decipher in getting that simple pattern out of a loop. Okay, and I keep emphasizing this is the kind of stuff that programmers do. You'd be surprised, like in writing real software. No one's going to pay you money to write the code that prints this. But when you look at what real programmers do, the thinking patterns are a lot like this. You're breaking down something into parts. Here we broke it down into that part and that part. The first and last rows looked alike, and we made that a separate thing. And then we say, okay, now we do the middle part. Then each one of these rows, well, there's a number at the beginning, then a certain number of spaces, and then there's this thing in the middle that's all we know that's kind of separate. Then there's these more spaces. You have to take a thing and break it up into sub pieces that you can write code to describe the sub pieces. So breaking this up into its pieces and building up those pieces in code is exactly what a programmer has to be able to do. It doesn't look like it would be real programming, but it is. Okay. Now, why don't we have you write real programs? because real programs take a lot more knowledge than this. A real program would be communicating with a database server and doing steps in between communications with a database server. And there's just way too much you have to learn before you can do that. So everybody teaches you to code with these little patterns, because these little patterns they do include almost everything you need to know. The way of thinking, they really do include all the ways of thinking that you need. It's just, and we're doing it with little patterns. Okay? And then you'll replace these little steps in the patterns with bigger steps, like communicate with a web server, communicate with a database server, uh, draw something in a graphic system. But you'll still be taking a problem and breaking it up into pieces and figuring out how you can piece the pieces together. So that's the thinking we're learning, is taking a problem, breaking it up into pieces, and figuring out what'll build up the thing. In this case, it's for loops. For loops mixed with methods. Yeah, yeah. Oh, now I could have, if I wanted to see this code right there, I could take it and put it right there and put it right there. Okay. Would that make my program better? Not really, you know, because now things are just more complicated. This code is getting way longer. Okay. Now let's see, I can compile it. See, it compiles. And if I run it, I get the correct output. See, I didn't change the program, but I think I made the program even harder to read, because now you get here, okay, this thing draws that shape. And first of all, you have to figure out that this whole first loop is just drawing that first line. Now you can put a comment, draw the first line. Okay. All right. So that helps. But, oh, actually, I'm sorry. Well, that comment is really for this whole block. Actually, I'm sorry. That comment is for this whole block. So how do you know, so what would you do? How do you specify that whole block is drawing the first line? You don't want to do this, I'm drawing the first line. I'm letting you know that this is all drawing the first line up to here. Okay. Okay. Now that's not making anything better. Okay. So all that drew the first line. Well, it's way better to have it just called a function, one line. See, that's why methods can make your code, or learning to organize things in methods can make things a lot nicer. Okay. Now down here, I would have to say that all this code from here on is draw the last line. Okay. But that's just kind of dumb. It's better to have just taken this block, and this block of code is exactly the same as that block of code. So it's not nice to have them repeated. Makes people think twice as hard. They have to analyze it here, then they have to reanalyze it here and realize, oh, you just did the same thing. But they had to read all this code to say, oh, you were just doing the exact same thing you did up here. The comments help, but you can't trust them. People will write comments and then they turn out to be wrong. So the comments are a clue, but you can't actually literally believe them. You have to verify them. So if this says, you have to figure out that this is drawing the first line over here. Okay. So writing this as a method made things much better. So one line of size. So, it's way better to just say all that is one method call. Okay. That makes things way easier to read. And that's important. That's an important lesson about methods. Methods are there for two reasons. They're reusable. That's what we're using it for here. Draw that pattern, draw that pattern, draw that pattern, draw that pattern, and I can keep changing the size of the pattern. Okay. So that's one thing. So the methods are so you could reuse them. The other thing that methods are for is so you can write your code in a clearer way. Here I'm using method in the other way. I'm using a method to make my code clearer. I've taken a chunk of code that was repeated 2 times and put it in a method so that I can just say one line of size, size, one line of size, size. Okay, so that's 2 reasons for having methods. Reusable chunks of code, make code easier to read. Okay, this is being reused, but this one's not being reused in the same way that this one's being reused. This is something that builds the whole pattern. This one's only really useful right there as part of that pattern. Okay, in fact, this one could be called a private method. Well, later on, we'll talk about why you do. If I call that private, what I'm really saying is that this method's not needed by anybody but me in here. Okay, so I could call that a private method. Okay, and then I can use it and nobody else can use it. Now, my patterns are public. So I'm essentially saying anybody can, not just the main method could use these patterns. Anybody could, I could have a little library of patterns. Okay. So anybody can use my method that draws the pattern. I need a private method that helps me draw my pattern. Okay? And then over here would be another public method to draw the pattern. We'll look in a minute here, a different way to draw the pattern with a public method. So I would make this method private as a way of saying it's not a general purpose method. It's a helper method. It made this thing simpler. This is a general purpose method. It's a public method that people can use over and over again to draw different size patterns. Okay. Now, what about okay, let's draw this pattern another way. Notice that this one seems to be a lot simpler. Okay, yeah, this was a we just outlined this way of drawing the pattern. Now let's think about another way to do it. This one uses logic to draw the pattern. Instead of, notice that this one's got a lot less code. It's just got one pair of nested for loops with an if statement in it. Okay, all there is for loop, if statement. Here I had method call, for loop, then for loop with a for loop in, I need to get rid of that. I replaced that with the method call. Okay, so I've got a method call, then I've got an outer loop, and inside the outer loop, I've got a for loop, and then print something, then another for loop. So I got successive for loops nested inside of a for loop and 2 method calls. It's a lot going on. This other one's got outer for loop, inner if statement. That's it. Okay. What does it do? What it does is it treats this guy as a box, treats him as a square box. And he's got size -1 columns and size -1 rows. Okay, remember we counted earlier that this is 1, 2, 3, 4, 5, 6, 7 rows, 7 columns, 1, 2, 3, 4, 5, 6, 7 rows. And but 7 is what you get when you count up from 0 to 6. So if you count up from 0 to 6, you've got 7 things. So I'm going to count up from 0 to, now here I'm going to use that less than or equal to case. I'll use it here because I want to go from 0 up to 6. And here to me, it's easier to write that with the less than or equal to. I would think it'd be kind of dumb to write that up to, but not including size +1. Okay, now I think that would be kind of a dumb way to write it. So I will use the less than or equal to in this case, because I think now it actually is clear. I'm going from 0 up to and including size. This loop is picking the rows. Then this loop is picking the columns. It's going to do the same thing from 0 up to and including size. So it's treating this as a box, a grid with 7 rows and 7 columns. Okay. Row is what row you're in. Column is what column you're in. So you can think of now as row column as being an ordered pair. For example, right there, I have a coordinate. I'm in row 1, column 1. I'm in row 1 because that's row 0, row 1. That's column 0, column 1. I'm in row 1, column 1. This guy's in row 2, column 2. This is in row 2, column 1. This is row 2, column 3. Every place in this grid has a coordinate, what row it's in, what column it's in. So that square dot, this one here, it's in row 0, 1, 2, 3, row 3, column 0, 1, 2, 3, 4. It's in row 3, column 4. Okay, so this loop and this loop are picking the rows and columns. Then the if statement says, if a certain condition is true, I print out the column number. Otherwise, I print out a space. Okay? And it turns out that if you look at these numbers, that's column 0. It's filled with zeros. This is column 1, and the only thing in it is either 1 or spaces. This is column 2, and what's in it is either spaces or the number 2. Notice that this is column 3, column 4, column 5, and column 6. So you notice that I'm in every place, I either print the column it is or a space. I either print the column number or a space. Here I print the column number, below it I print the space. So in every square in here is filled with either a space or the column number. So then the logic is, if the column is 0, print the column number. That's the left edge. If the column is size, print column. That's the right edge. If row equals column, that means I'm on the diagonal. You print the column. Every place else, I print a space. Okay, so I print the column number on the left, the column number on the right, and the column number on the diagonal, and then I get this real elegant way to print that shape there. Okay, and the logic is real simple. It treats this picture as a grid and says, tell me what to do at every coordinate in the grid. So at every point in the grid, I have a coordinate, what row I'm in and what column I'm in. And from a little bit of logic, I can figure out whether I should print a column at that place or a space at that place. Okay? So that's that's a real big change from this one thought in terms of as I march from top to bottom, and as I march across each row, what do I do? Okay, so it treats it as building the shape really step by step. Print the first row. Print, for each one of the next rows. Each row, you work your way across the row. Print a 0. Print a bunch of spaces. Print the thing on the middle. Print a bunch more spaces. Print, so you really work your way across each row. This one steps back and takes kind of a holistic point of view and just says, is there a real high level description of that shape? And there is. It's a square grid where at every point in the grid there's a coordinate, and depending on what the coordinate is, you're going to print always either space or what column you're in. You only print either what column you're in or space. And then here's the logic that says, if you're in the left column, print that 0. If you're in the right column, print size. If you're in the diagonal, print the column you're in, what row or column you're in. If you're in the diagonal, it doesn't matter if you think of this as a row or column, they're the same because you're at where row equals column. So that's a real interesting way to treat it. Turns out this is the computer graphics way of treating it. This is treating this guy as a computer graphics grid and saying at every pixel in that grid, I need to decide what to put at that pixel. Pixel stands for picture element. So this is actually a computer graphics way of thinking about that picture. In fact, almost all these pictures could be done that way. Almost all of these pictures, there is a grid way to think about them. Some of them, it makes it easier. Some of them makes it harder. But you could think of that as a grid. So every point has a coordinate. And then you could think, well, what do I do in that coordinate? And many of these can be turned into a grid one, though some of them it makes them easier. Some of them, it makes it actually harder to think in the grid case. This one, it made it easier to think of it as a grid. Okay. So that's kind of a funny thing to really change the point of view and draw the program to draw the pattern a really different way. Okay. Like this one turns out to be real easy to draw in the grid way. You can get this one real easy because every the only in terms of the grid, you either draw a star or a space. If you're in the top row, bottom row, left column, or right column, you draw a star, otherwise you draw a space. So that would be if the column is 0 or if the column is size, if the row is 0 or the row is size, you draw a space. I can actually do it real quick. If the column is 0 or the column is size or the row is 0 or the row equals size, okay, this one should draw now the box. See, it drew the box. See how easy it was to draw the box. Okay. Now I didn't change it to being stars and spaces, but see that one's real easy to think about as a grid. That one's real easy to think about a grid. So is this one here. You just add the diagonal. I can go here and put back the or row equals column. If row equals column, I'm on the diagonal. There's the box with the diagonal down it. You know, this is really a clever trick. This thinking of it as a grid it makes some of these pictures real easy. Not all of them, but it makes some of them real easy. Okay, well, we'll quit there. We run out of time. So now what I want you to do is there's a lot of examples in this folder. Look at them. Read them as like the textbook. There's a supplement to the textbook. Start reading code. Read these examples are kind of good examples. Each one does a kind of an interesting little pattern. In this case, think of that your job is to understand why each one works. Okay, so you would read each one of them and understand why it works, why this one draws that picture. Okay. Okay. Yeah. Now I didn't do it as the grid way. This one's not doing it the grid way. It's kind of doing it the kind of the harder way, but it also because it has a lot of different. That's because it wants to do all kinds of different. It doesn't uniformly put the same thing here as it did here. So if I did this one the grid way, it'd actually be kind of messy. Okay, but so you want that picture. Read the code. What is this guy doing? What's this thing doing? What's this doing? Figure it out. Read the code. Practice reading code. Okay, so that's your assignment, is to practice reading the code to see that you can say what this was doing and what this was doing. Okay, anybody any last question? Okay, so we'll start talking more about methods on Wednesday. So you got a reading assignment about methods, and we'll oh, wrong browser. No. Well, there's a reading assignment about methods. We'll talk about methods and we'll talk about these examples because these examples are good examples of using methods too. So they're all good examples of methods and they're good examples of nested for loops. So we'll do a few more of these examples and we'll talk about how they also give us an idea of what it means to do math. They do everything but return values. Okay, we have to talk about return values. None of these have a return value. So they talk about methods and parameters, but they don't talk about return values. Okay, so think of these as part of your textbook. Read them to understand how they work. If you have questions about them, please send me email or come to office hours. Okay, so I'll quit there and let's see. And then, like I say, on Thursday, we'll talk more about methods and more about these examples. All right, so see you on Thursday. Bye.